Welcome back. In the last part of this section, we're just going to do some more examples involving permutations, factorials, and combinations. All right, example 8, we've got 500 entrants all running in a marathon, and then we're giving away three places, first place, second place, and third place. We can assume that we're going to give away all of these medals and that there are no ties at all in this race. So we're not going to have anybody tied for second or tied for third. So there will be three different people who are going to win the marathon. And the first thing to ask ourselves is, does order matter for this? And so there's first place, second place, and third place. So let's pretend that the three people who win is person A, B, and C. So let's pretend these are the winners of the marathon. I'm going to ask myself, would it be the same thing as if A got first place, B got second, and C got third place? Would that be the same marathon if C was in first place, A was in second place, and B was in third place? The answer would be no. That's not the same results for the marathon at all. That's completely a different result. So that's telling us order certainly matters here. So we should be doing something involving a factorial, maybe a permutation. So now what are we doing? Well, there's 500 people. There's three of them who are going to win, and they're going to win in some kind of an order. So in other words, we're doing a permutation. Out of 500 people, we are just selecting three of them to win, and then we're arranging them in first place, second place, and third place. So just P503. Which is a shockingly large number. So that's something else just to also mention as an aside as we're getting into more complicated counting questions. We're going to find that for a lot of questions, there are many, many ways for us to complete an activity. So for this 500-person marathon, there's millions, hundreds of millions of ways, 124,251,000 to be precise, ways for this marathon to give away just the first three places. It's quite a lot. All right, another example. So we're going to a chicken wing restaurant. So all they do is chicken wings, and when you get your order of chicken wings, you have to choose three different sauces because it's just that kind of restaurant. You're not allowed to choose ranch three times in a row, so too bad for us. That is a sort of question we're going to want to think about, though, and we are going to tackle tougher counting questions where maybe we can't just use just a factorial or a permutation or a combination. But this is a nice restaurant, so they've made things easier for ourselves by saying that we are forced to choose three different sauces. Question is, how many ways can we choose our different dipping sauces for our order of wings? And so now I have to ask myself, I'm picking three different dipping sauces, and so let's suppose I'm going to choose barbecue, and I'm going to choose ranch, and I'm going to choose chili. Okay, great. Would that be the same as if my server came to the table and I said I would like chili, ranch, and barbecue as my sauces? That would totally be the same because, of course, they're just going to put these three sauces on the side of your plate. They're not going to put them in any sort of like you get it at the beginning of your meal and the second one you get at the end of your meal. They're not doing anything like that. You'll get all three of the three dressings simultaneously, all three sauces simultaneously. So once you've ordered your sauces, there's really no way to tell what order you place them in. So barbecue, ranch, and chili would be the same thing as asking your server for chili, ranch, and barbecue. This is something where order does not matter. So that's telling me we're just doing a combination. So in this case, we have 15 things, and all we're doing is we're selecting but not arranging three of them. So our answer should be 15C3. And 15C3, when we compute that, is 455. So 455 ways for us to choose our sauces at the chicken wing restaurant. Just as a little aside, we're going to talk about decks of cards for a minute. Not everybody plays card games, so it's good to sort of review the details. specifically because we're going to be talking about cards quite a bit when we get into probability, because we'll have all sorts of questions about, if I deal you a certain number of cards, what's the probability that this or that might happen? And part of that's because really probability as a discipline started in the studying of gambling, believe it or not. But just to leave the probability side alone for now and talk about the decks of cards themselves, when I talk about a standard deck of cards, then it has exactly 52 cards in it. So there are no jokers, there's no instructions, a piece of paper slapped in there, just 52 playing cards, and that's that. If you wanted to subdivide it, half of the cards are red in color and the other half are black. So we've got two colors, 26 red and 26 black. And on every card, there is two things. There's some sort of a denomination or a rank. That's the number. So it's an ace or a 2 or a 3 or 4, 5, 6, 7, 8, 9, 10, jack, queen, king, one of those things. So you might have a card that's a 7, and that would be the denomination or the rank. And then there would also be a suit. Either it's a club or a diamond or a heart or a spade. So your card might be the 7 of hearts. As far as the suits goes, there's 13 of each. Of the 52 cards split into 4 groups, there's 1/4, there's 13 of the cards that are clubs, 13 diamonds, 13 hearts, 13 spades. And then as far as the ranks goes, for every one of those ranks, there's 4 of them. So, for example, the ace that we have, there's 4 of them, an ace of clubs, diamonds, hearts, and spades. There's a 2 of clubs, diamonds, hearts, and spades, and so on. One other little further subdivision, there's 3 special cards, the jack, the queen, the king. We call those face cards because on the card there's a picture of a person. So if we wanted to think about it, there's jack, queen, and king. There's face cards, and there's 4 of each, 4 jacks, 4 queens, 4 kings. So how many face cards? There should be 4 times 3, there's 12 of them. 4 jacks, 4 queens, and 4 kings. And so that means if we've got 12 face cards, then the number of non-face cards, so all the remaining ones, if there's 52 cards in total and 12 of them are face cards, then the other 40 are not face cards. So lots of numbers to sort of keep in mind. 52 for the total number, 26 for colors, 4 for how many of each rank, 13 for how many of each suit, 12 face cards, 40 of them not face cards. Okay, let's do some examples involving cards. For this one, I'm going to select 5 cards from a standard deck. So for the first part, we just want to know how many ways are there for me to select my 5 cards out of the deck. And in the deck, there's 52 cards and with no restrictions, so just selecting any 5. You'll notice for this one, we explicitly said selecting, so it's pretty clear this is going to be a combination. But of course, if you play cards, you'll know that generally when I give somebody a collection of cards to play with, it doesn't really matter what order I give you the cards in. So if I give you a 2, 3, and a 4, that's the same as me having given you a 4, 3, and a 2. So for card questions, generally it's always going to be combinations. And in this case, out of the 52 cards, we're going to select 5 of them. So there are 2,598,960 ways for you to select 5 cards from a deck of 52. And this is the no restrictions answer, which means all the other subsequent ones where we do have restrictions, we should expect a smaller number for our answer. Okay, how many selections are possible where all the cards are red? So for this one, I need to select my 5 cards only from the red cards. So not from all the 52 cards in total, but just from the 26 cards that happen to be red. So out of the 26 red cards, I will choose 5 of them. 26C5, and there's a lot less options available. So if we just wanted red cards only, there's only 65,780 possible ways to select 5 cards that are all red. What if we wanted to have none of the cards being face cards? So we're selecting only from the face cards. We said on the previous page that if there's 12 face cards in total in the deck, then there's 40 that aren't face cards. So if I wanted to make sure that I'm selecting 5 cards and none of them are face cards, then it'll look like 40C5. That would be out of the 40 cards that are not face cards, selecting 5 of them. That means 658,008 of them. That's the number of arrangements, or sorry, number of selections rather, of 5 cards from the deck where you don't get any face cards.